Ladies and gentlemen, my name is Ronald Adamaco, the Doctorate of Civil Engineering program at MSNT, and today we're going to talk about dynamic machine learning modeling. So, dynamic machine learning modeling approach. Murphy law tells us that data has doubled exponentially with time. Now, in the 2010s into the 20 teens, we know that data science became very popular. And this is particularly important once we look at part two of the slides, is because we are able now to leverage machine learning to find insight and empirical data in which we weren't able to do before. So I developed a computer science approach that would allow me to both take input and return results while remaining nimble enough to update itself when it sees new data. And this is particularly helpful when we're dealing with data that has anomalies, such as ACI, American Concrete Institute's shear data. And if we look at slide 3, this is particularly a problem because we can have shear failure that results in concrete structures breaking before the load that they were designed to fail. And what does that look like? If we look at slide 4, shear failure is a lot like slicing a cake, right? The knife represents a force, the cake represents the concrete structure. When the force is applied in a sharp way, it fails sharply or catastrophically. Now, we know that no two cooks bake a cake the same, and that is very similar to concrete. Concrete has a bunch of ingredients, so the objective is to improve prediction modeling and user integration for large nonlinear data. And how did we do that? In our analysis, we were able to detect the most statistically significant variables or ingredients of concrete, and we were able to apply the DMLM approach so that we can have a reliable output. Now, those are our results. Now, the conclusion is that the DMLM approach can result in safer structures because we have more reliability, as we look at slide 5. And finally, this proof of concept would encourage others to use the DMLM approach so that folks can have their beams, structures, and eat their cake too. Thank you so much.